Hello, everybody. My name is Mark Guzdial, and it is my job to keep Nick awake. So I'm going to talk about what liberal arts and science students should know about generative AI. So at the University of Michigan, we're creating a new program in computing for the arts and sciences. So it's explicitly not part of the computer science department, nor part of the School of Information. This is the liberal arts and sciences saying, you folks are never going to build computing education for us. We're going to do it ourselves. And so I get to direct this program. And we are creating new courses explicitly for students in humanities, arts, and sciences. And I sort of got forced into it. Mark, you need to do a course on generative AI. Wouldn't it be great to teach humanities students about generative AI? And thus I am signed up for it. So what I'm going to talk to you about is not an existing course. I have no data at all. The course doesn't exist yet. But I am going to tell you about what we're trying to figure out and what we've been doing so far, which I think is relatively novel in thinking about how to build computing courses. It's really important, though, to recognize from the start is that my students don't look like anything that we've talked about so far today. Maybe they're closest to Henrika's teacher students, this people who are going to be future teachers. But my students don't want to be software developers one day. They actually find programming really frightening. So how do I teach them about computing, where programming is a tool for helping them learn computing, as opposed to something scary that they don't really want to learn? So here's the story that I'm going to talk to you about. So why would we do this in the first place? Why should we as computer scientists worry about teaching arts, humanities, and science students? And then how do we decide what to teach when, for the most part, we know, talking about these issues of competencies, we think about the competencies of future programmers, of future software developers. What are the computing competencies for someone who's going to be a humanities scholar, or an artist, or a social scientist, or a natural scientist? That's my challenge. And we use participatory design, and I'll explain a little bit of that process. And I think that our biggest challenge right now with thinking about generative AI is making choices between what is teachable and what is the expert's perspective. And I don't think these are all compatible. So I'm going to start out with history because I'm a history geek. Anybody in this room know who this is? Besides Barb, because she's heard me talk before. This is George Forsythe, who's a mathematician at Stanford, who Donald Knuth claims is the first person to publish the term computer science in 1961 in the Journal of Engineering Education. In 1968, he expanded on that phrase because it literally was just the words computer science. But he says the computer is a most important tool for learning science, mathematics, or engineering. So as early as the early 1960s, here's George Forsythe saying, everybody ought to learn about computer science. It's going to be necessary for how we learn in the future. In 1961, the MIT Sloan School had this amazing symposium on computers in the world of the future. And this book by Martin Greenberger that came out in '62 has all of the lectures and all of the discussants' notes. One of the speakers was C.P. Snow. Folks may know him from his book, The Two Cultures. He was a scientific advisor to the British government during World War II. He wrote this book bemoaning what he saw as the split in Western culture between the humanities and what we now consider to be STEM. He made the argument in his chapter that everybody should take a course in computer science, explicitly including programming. And his reason why was sort of a carrot. More sort of a stick. You'd better. And his argument was amazingly prescient for 1961. He recognized that software was going to rule the world. And he was afraid, quote, a handful of people having no relation to the will of society, having no communication with the rest of society, will be taking decisions in secret which are going to affect our lives in the deepest sense. Is this not amazingly prescient for 1961? So his concern was that everybody ought to learn about computing and programming in order to keep it under democratic control. The first time that I did this slide that Michael Casperson saw, he said, Peter Nauer, the Danish Turing laureate, said the same thing, as you can see here. For the rest of you who, like me, don't actually speak this, Michael provided me with a translation. I want to emphasize this last part. So Peter also argued that informatics should become well established in general education, and one of his reasons was for ensuring that their use do not become a matter for a small group of experts, but become a usual democratic matter, and thus the democratic system will lie where it should with all of us. Again, making this argument that democracy is at risk if only a handful of people know how to control this very powerful technology. Now, back at that Computers in the World of the Future, there were actually two speakers that day who argued that absolutely everybody should take a course in computing and that it should include programming. And the other one was the first ACM Turing Award laureate, Alan Perlis. Perlis at the time, who then went on to create the computer science departments at Yale University and Carnegie Mellon University. At the time, he was at Carnegie Tech, and he talked about how programming changes the way that you understand things. That he says that you can't think about integral calculus the same once you learn about iteration and being able to index things by very small amounts. At the time, Carnegie Tech's business/economics department was creating simulations. In general, we don't think about economics of a company or a nation as being an experimental basis. Hey, let's devalue the dollar tomorrow just to see what happens. But when you have a simulation, you can. So Perlis explicitly in 1961 saw the power of computational science and engineering, that we could think about exploring things and thinking about them a new way with programming. The first published definition of computer science came out in 1961 by Perlis, Simon, and Newell, and it was the study of computers and all the phenomena surrounding them. This is probably broader than most people define computer science today. We're going to call this computing, right? I'm going to come back to this later. So this is the definition of computer science that Perlis, Newell, and Simon gave us. Here's the one literally from the encyclopedia. Notice that society and all the other things are missing. Here's the one that is used in the ACM IEEE computing curriculum. Again, there's nothing about society and its impact on. Whichever definition here that you best like, I hope you'd agree with me that the first one is a lot broader than the latter two. Somewhere along the line, we started to find much more narrowly what is computer science. So I argue that we need to teach arts, humanities, and science students about computer science first to promote democratic values. One of my colleagues points out is that where will future policymakers in the United States more likely come from? The computer science department or my liberal arts, humanities, and sciences students? To give students a tool to think with. That's what Alan Perlis and that's what George Forsyth were arguing. It's also part of the earliest definitions of computer science. In some sense, the people who defined the field, they gave us our marching orders. This is part of our job. And finally, it's part that we left behind. Somehow, somewhere or other, we dropped it out. So I've been developing these new courses for this new program. Our course code is Computing 4, Comp 4, not computer science, not computing. We're about computing applied to other things. And I've been teaching these first two courses, Computing's Impact on Justice from Text to Web and Computing for Creative Expression. And next semester, I am now promised to teach a course on generative AI called Alien Anatomy. I love that title, how ChatGPT works. It's not mine, it's Gus Everart's, but I love it. Okay, so how do I decide what should be in a course on computing for ethics or computing for justice or computing for expression? It's not like I can go up to the ACM IEEE computing curriculum volumes, just pull the one off the shelf and says, oh, this is how you teach justice students about computing. So what I decided to do, I used to work with Betsy DeSalvo at Georgia Tech, who literally wrote the book Participatory Design for Learning, and she taught me participatory design methods. So that's what I decided to do. So I grabbed a group of faculty who self-identified as I do computing for justice or I do computing for expression. And I gave them shared whiteboards and asked them to move the learning objectives which were on these whiteboards to the right if they wanted to keep them and to the left if they didn't want them anymore. Okay, so I'm only going to show you a slice of this. This is the end state. These learning objectives are coming. Actually, I have these in hard copy if anybody wants to see them later. So these are the end state. I took all of these learning objectives from our earlier work where we did this big task force report on what do people in liberal arts and sciences want in computing. So move to the right the things I want. So you can't read all that. Let me zoom in on the right. So here are things that people who care about justice think are the critical parts of computing. Okay, and I'm going to speak more to these in a little bit. I want to also show you what's over on the left. All those things that we most think about being in a computer science program are those things that they move to the left. They don't care about students learning how to write secure, safe, and robust code. Now, computer scientists may be affronted at that, but it's critical to write safe, secure, and robust code. Absolutely. Somebody should. Does everybody? Do all humanities students need to learn that? And could that might get in the way of what they want to do with computing and what they might be able to do powerfully with computing? So these things in green, so these are my standards, right? This is what's been handed down to me. Whether or not I like them, whether or not I choose them, that doesn't matter. It's a participatory design process. These are my standards. The things which are boxed in green are the things which I'm already dealing with in our justice course now. These are the ones that I hope that I can get to in the generative AI course. So we've been using just per design. I want to take one thin slice to explain how we're doing this in the justice class. And then I'm finally going to get back to the generative AI topic. Okay. So I have dozens and dozens of hours of interviews now with liberal arts, science, and humanities faculty asking, so how do you use computing in your discipline? What do you want your students to know about computing? How should I teach them? So this is Lakeisha Simmons, and she's a history professor. And I'd heard about her that she was building websites to explain history research to the general public. And I came up to her and I said, so I hear that you build websites. She said, no, I don't build websites. My students build websites. I don't know anything about building websites. Okay, no worries. What would you like your students to know about computing? For example, I could teach them about the internet. I could teach them about packets and domain name servers and clients and servers. She said, no, I don't care about any of that. She said, I have a very specific list of things that I want my students to know. First, that there are things called databases. Second, that databases, if they are designed well, are easy to index and find information in. And then with the press of a button, databases could be shoved through a template in order to create a website. I'm sure that all of you know a lot about things like packets and servers and clients and domain name servers. I think you'd all have to admit that this is an orthogonal slice and probably covers what, 60, 80% of the internet is these three things. It's a very different way of thinking about what is foundational about the internet. So that thing in the upper right-hand corner, what all of my justice scholars said they most wanted students to know, that's where this came from. They all want this. I was a little bit surprised. I wouldn't have thought this as being the foundational thing for justice, but this is what they want. So that's my challenge. What's really interesting, and I think starts to get at some of the issues we've been talking about with large language models, programs don't start with this. If I went to ChatGPT and said, could you please explain to me how I use a database to create a website? It's going to start talking to me about things like variables and loops, none of which is what these students know about first. That's not where they want to come at it first. Do we have to start with that earlier level? I'm really inspired by this work by Mike Tissenbaum and his colleagues, where they talk about alternative paths for alternative endpoints. What would it be like to rethink the computing curriculum, where we're not trying to just produce software developers? We want to provide computing skills to a wide variety of students. I think that this makes us ChatGPT resistant, because we're not about the same endpoint as what the rest of the large language models are about. So I've got to teach students about databases without teaching them about all the other things like variables and semicolons and curly braces and for loops. So one of my undergrads, we use Snap, a block-based programming language, so we don't have to worry so much about syntax, no curly braces or semicolons. And she created a set of blocks to manipulate tables, CSV files, as if they were SQL. These are SQL-like blocks, and we can assemble them even to do things like queries, manipulate data. So I can teach ideas of SQL and databases without having to deal with variables and textual lines of code. Now, the real challenge was I now have to take a database and generate web pages. And I had promised my advisors, we'll do everything from the web, from a browser, nobody will have to install any software. And I'm thinking, how am I going to explain FTP and servers and uploads? And then realized we have this super powerful tool in Snap. We built custom Snap blocks. Here is how to build a web page. Okay, so I'm emphasizing the hierarchy and the encapsulation. This really does generate a web page. It appears in the stage. It really does open a page with these pieces. And I can now use these blocks so I can do a search. So this is going through Forbes database of billionaires, pulling out those who work at Microsoft and sending a form letter to them asking them for money. Okay, again, this is ChatGPT resistant. There was just a recently a paper, I think it was at a TIXI. LLMs don't know how to do Snap, and they particularly don't know how to do my custom blocks. All right, so here is where I'm at now. I want to now figure out, how do I build things that are teachable like that? I just built a set of blocks so that I don't have to start where we normally start with computer science, but I can teach about web and database. So I can jump to what is in computer science, the endpoint, right? The farthest advanced stuff, but I can do that first. So I would like to actually teach something like this. I want to be able to explain how I can take an image, feed it through a neural network, that there's back propagation, and I can actually make an estimate about what this thing is. I was really kind of expecting Mati and Enrica to put this image up. They did a wonderful job at Atixi, making this Gen AI teachable machine doing rock, scissors, paper. Yes, that's me, and that's me replicating the demo that you did there. And I am definitely planning to use this in my course. But I want you to think back to the goals. This is about democracy, and this is about helping them learn. This certainly helps students see how a classifier or recognizer works, but it doesn't give them enough to understand what's going on behind the scenes. So I really love the work that Jens and Jagda are using in Snap with their gesture recognizer. So the idea is I can see what the training set is. It's learning how to recognize a gesture. I get a piece of code, and I can read the code that is keeping track of all the mouse points and generating a sketch. I can add my sketch into the list of examples. So I build the training set. And then by adding this block to that, it now becomes a recognizer. And you say, well, what does it mean to recognize? Well, if I want, I can dig into the code and I can see that what it's doing is for a minimum distance from the things which are in the training set to the sketch that I just made. There's no neural nets here. There's no real classifier. But the idea of I have to build up an example set and I'm going to compare my current instance to the things which are in the training set, that's all there. I can go one level below the surface, but I still don't have to teach all the stuff about variables and semicolons. Instead, I can say, let's think about the concepts here about what a recognizer is doing. I've been going through the Fast AI course by Jeremy Howard. This is the code in his first lesson of his course, the YouTube video. I have the captions turned on. This is going to be great in the next scene. We're actually training a model here. Okay, you can see the Python code here. And here's then where we do a prediction. We're recognizing a bird picture. I happen to love that I caught this caption since the captions were turned on. This doesn't take any math at all. I mean, it's pretty accessible. And I don't know about you, I've written a book on Python. I can't read all of that. I don't know what's going on here. This isn't all that accessible. I mean, yes, the math that's involved here is not obvious, but the math that's necessary to understand all the things which are hidden here, to know this level of Python, is pretty significant. So I've been looking into things like, there was recently a Kai workshop in AI literacy, and other folks are working on this problem too. I really like this work from Xi Lu, where they're trying to help students to understand the algorithms behind generative AI. So being able to figure out the centroids of a bunch of data, actually being able to compute entropy, and they're using whole division so students see the algorithms. And so they're going to talk about the terms like entropy and loss, but they're not necessarily showing us the algorithm. So that's still missing. I mean, this is sort of, Monty made this really interesting point about, we say we're doing computing education, but too often we're doing programming education. I really want to do computing education, but I want to use programming to get there. Which means I'm not going to necessarily teach Python, R, et cetera, but I make my own languages, which then LLMs don't necessarily know. So I really like this new work by Eckhard Montrow, where he's creating a set of blocks that really can do generative AI. So this is the space that I'm trying to explore, where I can't do Jeremy Howard's expert level and make it work for my arts and humanities students. But looking at the blocks gives me a way of trying to do the real thing, but do it in a way that students can look underneath the covers. So here's a summary of where I'm at. Why am I trying to do this at all? Because it's about democracy. It's about giving my students learning power. And I'm trying to get there by using participatory design. What do the faculty in these areas really want me to be doing? And I'm trying to reach this point where I can teach students I can give them a democratic understanding and understanding how they can control AI by inventing new abstractions that sit above all of these levels. Thank you. I think I got 5 minutes for reference.